started. I'm going to do a little bit of PowerPoint, and the rest of it is going to be an interactive demo. So when we get to that part, when we get to the point where there's like code on the screen, if you can't see in the back or even in the front, depending upon how much like my eyes your eyes are, just like go like this, and I can zoom in so we don't have to sit here squinting. So good morning. Thank you for coming. If it were me, I would be at home and waiting for the YouTube video. So I appreciate you. I hope you had a wonderful time last night. Unity always serves a good party. It was close, so it wasn't like a too short of a jaunt, and we made it here. I'm Hollie Figueroa. I'm a software test engineer at Unity, and in the midnight hours, I'm a developer for Knife Games. That contact info will be up again soon, but just for there. We're going to talk about testing for Sanity. I found out after being a test engineer that I'm extremely impassioned about writing tests for software development, and in my own games, why haven't I done that? And we all know there are reasons for not writing tests in your own game. It just needs to get outdoor. So I want to talk a little bit about test-driven development, which is what kind of got me started. This is the most boring slide, and the next ones will have GIFs to make them a little more interactive at 9 a.m. this morning. So test-driven development, broken down, is red, green, refactor. You sit down with your designer, you have a spec, you say, okay, these are the things that we need to do. You write tests that fail, so they're red. Then you write code to make the test pass, which is green, and then you refactor both the code and the tests to make them the pretty pieces of code that we want. One of the other than red, green, refactor, one of the other like philosophies is keep it simple, stupid. You don't need to write extra code. Often while we're like not thinking about what we had designed in mind, our scope just kind of creeps and we end up with lots of this superfluous code that's commented out here and commented out there, or no comments, and a lot of like, well, I tried this and then I ran it in the editor and that's not really the direction we're going. And it never ends up. So if you take a second, think about it, spec it out. You aren't going to need the extra code. Don't worry about it. The next one is fake it till you make it, which we'll talk a little bit more about later. This is very common to us already. We write in placeholder values, so the test pass, you do that already. You kind of like sketch out the main gameplay, the game mechanic, whatever it is that you're working on, and move on. So in a nutshell, that's test-driven development. The green, why it's so nice. We all like green. Green means money, green means go. It's kind of rewarding to see like the little green lights flash green, and you're like, ooh, an achievement. It molecularizes your code. That's not a word. I made that up. But it makes it small, simple, and concise, so when you go back to refactor later, it's these small, concise little nuggets of logic that we can consume faster. So test-driven development really does help this. You know it works sooner, so you didn't spend an entire day writing and then go to commit and be like, none of this works, and I've spent all day and I don't remember the breadcrumb that I left for myself because I didn't comment my code. You're refactoring right away, right? It's that quick turnaround, red, green, refactor, and you keep iterating. As you're writing these snippets and tests, the tests themselves are a documentation. So you're preserving this game logic that let's all be honest, the worst programmer we've ever met is us from 6 months ago. It was like 11, 12 p.m., you had already done a lot of work, but like the deadline's coming up, you have to pitch to a publisher, on and on, it's ugly. So that preserves the logic. What you intended to do is there, and then when you went back and refactored and messed it all up and your comments don't even make sense anymore, at least you have the tests to be like, oh yeah, this piece of code is controlling that ship movement in this scenario. They make them so they're short, focused, and readable. A test is either pass-fail, right? It can't be a long string of logic, so it's very sequential, and you can kind of like piece it together. It also saves the programmer versus designer. I am not on an indie team that's large enough to have a dedicated designer. There's only 2 of us, and we wear all the hats. But I've seen on teams that are slightly bigger where the programmer's like, okay, but you said this. And the designer's like, yeah, but like we changed it, and now it says, like, but you said this way.
you agree to have what the intent was and the test before you start writing the code, and it makes it a bit more, you have something to go back and forth. So there's a little less programmer versus designer. Fake it versus to do. Like I said, we always, you're gonna see in these scripts later, there's these lovely like to-dos. Make this not a hard-coded variable, right? Like you have this like, yeah, I just threw this in here, it's just placeholder for now. To do, change this to the actual art. To do, change this so it's a little more abstracted. The more abstracted we can get the tests, the more reusable they are, right? So this is, and it doesn't actually take that long. We're doing the to-dos anyways, just write it then and away you go. So this makes it really nice. There's a problem with this. I actually found out that I don't really like test-driven development because while the programmer has something, while the designer and the programmer have sat down once, there's never that iteration again. So you have all this tests that you've set up to like check for sanity, like, yeah, this stuff works, yeah, it preserved logic, but then that's kind of the end of it, and it loses its value in game design and development when we're trying to make things progress over time. It's not like it's software development. I mean, it is, but it's not, right? It's a whole different beast. So each time that we move forward, we're constantly iterating, and that design is changing as the game evolves and progresses. And if you want to get into game as art, to me, that is the art. The programmer's art is how this thing evolves over time, and in true test-driven development, that doesn't exist. So I like data-driven development. Data-driven development means that I can still have those tests, still test for sanity, rely on those principles, but get actual data out of those tests to feed into my designs and continue to make my game better and better. Lean programming still means that I'm getting data out of it, and so there's still short, concise little nuggets of logic, and I get to use, we get this back anyways in play testing, in our beta testing. If we're doing game perf and bug reports, that we get back, if we had written tests, we can plug those bug reports and the performance data into the tests, and now we have real world data that we're testing against our game, and we're like, okay, no, I really, that test passed, but that's not actually, or this test passed, but it was outside, the user is actually using it outside the scope, and I hadn't thought of that, so now I can add that test in. It relies on unit tests, which we'll go over next, and it feeds back into the design, which I've talked about for this entire slide. So it combines both these principles of test-driven development and the feedback loop of design-driven development, which is super nice. So how do you get data from your game? That's the Unity analytics part. But let's talk about tests first. Good test is automated, isolated, pass-fail, easy to read, fast, and not superfluous. You don't need a test for every single line of code. If you know that it's always true, you don't have to say, hey, test if this is true. And it's fun to write tests if you have the time, but you can get lost in them. Automated means that you should be able to hit play in the editor and it just does its thing. I'm talking about play mode tests. If you want to learn more about editor tests, that's a talk for a different day. They should be isolated and that you shouldn't have to have 3 tests run in order to get an output that you wanted. You should be able to select one test. This one user is running on an NVIDIA graphics card and got this result. I don't have the NVIDIA graphics card. What I do have is their value that they got back, and now I can plug that into my test and see what the result I get is. They need to be easy to read, as we've said, they should be already, and fast. It shouldn't have to be something where you wait for 30 seconds to a minute of gameplay. You're never gonna get the number of results back that you want. We already talked about the extra frog legs. Nobody needs those. Okay. This is not what we're doing. This is just a reminder to me to minimize this. Okay, so let's look at some tests. Don't worry, I will zoom in on this. Make it big. How are you doing so far? Everybody, we're done, we're mostly done with the PowerPoint slides. Was that enough? We'll get back into the, perfect. Okay, good, that's all I'm not a huge fan. I'm sorry? Oh, yeah. I just had to find the control. Okay, that's analytics. Okay, how's this? Everybody good so far? Up a little higher? Higher? Okay. We'll start there. Perfect. Okay, so you're always going to do a setup, run your actual tests, and then clean up. So I've broken these into 3 things. What we're doing here is we're just testing that I can load this scene. With Unity's integrated TestRunner, it's built on NUnit, which is built off of JUnit. Go look those up. The Unity manual has a lot, and the NUnit manual has even more. It's great to just read over, and we're going to go through it. So when you enter a play mode test, what's going to happen is it's actually going to load a test scene, and all your tests are going to run inside that test scene. That'll happen for you, but it means if you want to access a specific scene in your game and touch those elements in that scene, you have to load the scene. The new scene manager makes that super easy. You can just async load your scenes. It's great because you're going to get so comfortable doing this, you're going to start to do it in your own games, and your performance between scenes is going to be even faster. Great. So once you've waited and you've got the active scene, in my case, it's space 00, you can go ahead and say, hey, by the way, let's just make sure that this is true. I'm going to assert is true that my active scene is the space scene. Now, this is a hard-coded test. It means that I've hard-coded this in. This is not something that I can easily change. And eventually, this should change into a variable where space 00 is a string variable that I set whether in the inspector or via script or via remote settings, if that's the direction we're going. So this is great to start out with. This is the base scene to test that the very basis of loading into the game is working. The next one, because the project that I'm working on is an ARKit game, I want to make sure that I can instantiate the plane prefab. Everybody that was in the keynote saw the lovely blue rectangle. How many of you guys are working on AR-ish projects, ARKit projects specifically? Cool, this is great. I'm going to touch a little bit on AR-specific analytics as well. So I want to make sure that I can instantiate that prefab, and it is the prefab that I want. So while we start out with, we're going to use the default plane prefab, but that's not, we really don't want a blue rectangle in our game. So we're going to end up changing it and tweaking it as it suits our needs, and we want to make sure that that's working. So we load the scene just like normal, check that we instantiate initialize the plane prefab, set the test plane to the prefab that we have in from ARKit, and then assert that they're equal. Like this is how, it's not that hard, right? This is like pretty easy. And it takes all of 5 minutes. To prove that, we're gonna write our own right now. So, is the screen size still okay? Good, okay, nobody said anything otherwise. So, this is one that I have half set up. I have the scene load and the scene cleanup. And what we're going to do is in this project, there'll be ships that spawn, and they're moving via limicons, which is just graphical representations of math in specific patterns. And they move along the XZ axis and along the Y axis. Both of these things are set via remote settings. So it's a switch, it's this lovely, hopefully nobody's getting sick from me scrolling through there. Sorry about that. That was not as user-friendly as I want it to be. So it's this string that gets passed to a switch case. The switch says, hey, if it's one of these, what I want to test here is that this works. That if I type in something dumb that didn't match and it gets sent to the game, that it's not going to explode and we're going to be able to be just fine. So we're going to hard code this one again, but you could totally do it via variables. So we want to say here that y ship pattern equals y-axis is none. This is close to a variable that I have, but the variable that I have doesn't have the spaces. And so this would be a pretty common mistake that I would make at 11 p.m. after like a whiskey with a PAX deadline coming up. And I just want to make sure that that's not there. Now, because it's using remote settings, I need to make sure to wait that this gets set. So I'm part of the test tools, you can use TestRunner, is you can actually use an enumerator, so you can wait for frames. That's the difference between the TestRunner and straight up NUnit. You can't wait in NUnit as implemented in Unity. With Unity's test tools, you can be like, wait for frames, wait for end of frame, wait for so many seconds, wait for a fixed update, whatever it is that's the appropriate yield, you have the ability to do that. So in this, because it's a little time sensitive, I need to wait for a callback for it to switch itself up. I'm gonna go ahead and put a yield in here. Let's just do it for 1 for now. And because, as you saw, it said, hey, by the way, this isn't the correct string, you're dumb, I want to make sure that that happens as well. So I'm going to do assert. Oops, sorry, wrong one. I'll log assert. Expected, and it's a log type log, because it's just a debug log. And the message is this. And really, this is a nice way of telling myself, by the way, you fucked up. Okay, so in this test, the first thing I want to do is make sure that this log happens. I can preserve this log in the build, and I can also write logic that if this happens, I can send a custom analytics event to myself that includes this message or includes what the player was doing or the current remote setting that I had, how I goofed up, how this got messed up, and I want that information back. So then we're going to assert dot r equal, and we want the expected, which should be the new one up here. Sorry. So it should be the y-axis oscillation is what the pattern should be set to after this is called. Oops. And the actual is the y ship pattern. And just for funsies, let's run this in the editor. So to find TestRunner, you don't have to do anything special. You just go to Unity, TestRunner, voila, it's there. I'm going to enter my play mode tests. Here they are. And I can run all, run selected, or run failed. So we're just going to go, you can see here's my pattern script. This is the one that we were in editing. This is the y-axis is the wrong name. And I have a couple other in my OS. There's the plain prefab and the scene loading one. So let's just go ahead and run all of them. How are we doing on time? Oh man, this is so good. So you can see here's the test scene. It loaded my scene, and it closed everything out. I had something that failed. Turns out that the expected was the y-axis is oscillation, which we talked about, but it actually still hadn't changed over to the y-axis is none. So we can assume one of two things. One, it hadn't had a chance to change over yet, or two, I never told it to actually switch its name over. So let's check. Nope, I signed it as y-axis oscillation. So maybe we just needed to wait a frame in order to do it. I don't want to like count frames, so instead I'm just going to say, hey, after you do this, do another yield. And we're not too pressed on time right now, so we'll just wait for another second. Save, return back to Unity. And you can either return failed, which is all the tests that failed, so it'll only run those, or you can run selected. I know this text is small in the back. I'm not going to blow up Unity because it's not really, you can see it later. Let's just run selected. Again, my tests are working in isolation, so I don't need to run all the tests at once in order to do it. And we passed. That was it. We just need to wait for a frame. I need to go back through the update loop. Cool. Here's the pattern, or the console log. This is the other thing that's super nice. So I am gonna pop this up. I lied, because this is like super awesome. Okay. I don't know if I can make this bigger. This is super, super small. It tells me the test, how long it took to run, so it took 5.936 seconds to run, which is fairly long for a little test. I could go back and clean this up, just for demo purposes, we're not gonna worry about it. It tells me what the unhandled log message was, and it's saying that there was this is the one from before, that the expected string didn't match. And it's telling me that it's using the test tools. Here's our end unit framework. The next one down here is the one that passed. It gave me my ship patterns, which is a separate set of code. Didn't have it in there either. And here's the debug log, which is the correct debug log that we want it to have. Those are included with your test output, which you can save off to a JSON file or whatever other output you want. I can save to a string, which is nice. There's some cute little like run in all players. What do you want? Explore that later, but most of that. This is me the longest lull of the. Was that a bug? It said closing open Unity and Xcode. I don't think that was supposed to say that. Somebody submit a bug for that, okay? I'll deal with it on Monday. So then we can open up Xcode and complete this. Okay, so TestRunner, super easy, super straightforward, quick demo. Play with it when you get home. The limits are endless. You can have so much fun, and it ends up becoming a game in and of itself. It's you against your own logic, which is the best kind of fun. So I'm going to switch now and show you what this app actually looks like, what we've been working with, and show you now how you can do some of this analytics data instead. So don't steal my super clever name, space the final AR tier. Like, how original is that, huh? Well, there's my beautiful Made with Unity splash screen. It's a good thing I painted my toenails. You guys are like staring at my feet. Okay, here's our beautiful default plane. We tested that. Tap to spawn your cute little ship. Swipe to send them off. Tap, swipe, tap, tap, swipe, tap. Okay, good enough. Now if we follow this up, there just happens to be this whole fun little planet system in this awesome room. Now, if you see the trail renderer up there, that is my test ship. That ship is drawing this pattern. Like I said, that's the Limacon. And I'm using this to see how fast it should go. It's going ridiculously slow right now. Look at that. That's probably a bit too slow. But I like the shape that it's doing. I wish it was a little more up and down. I wish I had a better y-axis, because it's hard to hold this position for more than this conversation. So I'm going to go ahead and close this and not make everybody sick. And we're going to look at what this looks like on remote settings. Does this work? Oh, cool. Nice. I'm not going to show off the services window. You all know that it's there. If you don't, it's Control-0 or the little curly Q0 on your, and it'll pop it open for you. But let's go to Unity Analytics. So here's my space, the final AR tier. And these are the remote settings that I have set up. Is everybody familiar with just like the basic concept of remote settings? Yes, I changed the setting on the dashboard and it miraculously changes in the app. I don't have to rebuild. Those of you who are building in AR right now, you know that you build in Unity, build in Xcode, build to the phone, and test to see how many changes you've made. That ship is a little too slow and you gotta change a float. Change the float, build in Unity, build in Xcode, build onto the device, hold it all around. Shit, you can't find, I'm sorry, bleep that out. Bummer, you can't find a plane, like moving on. You know what I mean? Like it's the amount of time that you waste building sucks. So this is my super solution. So the ship pattern, I can go ahead and change. Ooh. It says that I'm logged out. Oh, no, it didn't. Super nice, handy thing. You have a release and a development stage. So if the app is already out and you're still tweaking with your design, you're not screwing everybody. You have a don't test and prod, right? Good job. Okay. So let's edit this. And we're going to change this to Lima figure 8. I have a figure 8 design. Again, Lima is Limacons. They're super fun. All of that is math. All that ship movement was math. There's no animations. There's nothing. It's just script running, which makes it super easy to change this. This is the angle divisible. I also thought the ship was running a little bit slow, so I'm going to change the speed. Because it's what the angle is divisible by, the lower the number, the faster it is, and the higher the number the ship is. Just math. There's this lovely sync button, and it's going to prompt me to make a commit message. That way, while I'm testing and tweaking variables, I can leave a comment to myself, I thought the ship was too slow. Change to figure 8 pattern. I thought the ship was too slow, so I sped it up. And it will save the history of what these settings are as well. And that'll be available in your data export. Okay, so we've synced that. Now if I go back to my app, just remember, I have not rebuilt this. This is going to be amazing. Okay, same app install. We're waiting a second for the Unity splash screen. Voila. Here's my lovely toes. My plane, just for giggles, let's send some of these ships up. I was lazy, and so you know when you do input.touch.move and you're supposed to have like if it moved this much, I didn't put that in there. So as you can see, they just spawn. Okay, now if we look up, hopefully I don't make anybody sick, you can see that this pattern is way different. It's doing a figure 8. And that ship is a little faster. Not too much, just a little bit, because we knocked it down a little bit. And now when I'm in my testing scenario, I can keep iterating on this design. I can send it off to Leon, who is my marketing manager, and be like, Leon, what do you think? Did you like this one? And be like, no, it's a little too high yet, Lily. Let's bring it back down. This still makes me sick. And we can be like, cool, we can go ahead and change that too, because we have a y-axis pattern, and right now it's set to none. So we can change this too. And you see just how much fun this can be. It saves you so much time. And on top of it, you have all this data now for yourself that you've kept track of. So if you look at your data explorer, just by turning on analytics, you get this basics, right? The things that you don't care about during development, like daily active users, monthly active users, who's spending money, what devices is it installed on, what is the SDK, what OS do they have. You get all that just by turning on analytics without writing code. When you do write 2 lines of code, you can get this. I'm really interested in how many ships people spawn, and I'm going to do all my current users, unique users, and I just want the count. Oh man, you guys are so nice. Thank you. Okay, so now you can see. Let's do number of ships spawned, and we're just going to do count. So these awesome users, which happens to be Leon and I on 1 million devices. That's my time. said you could start throwing things at me. We'll wrap this up quickly. This is the number of ships spawned. The really awesome part is I have started tracking quality, and I want to do ambient light. Turns out the AR is a lot like film. It's using a video feed. So if your light is too high, your film is now overexposed, and you can't track anything because it doesn't look like there's anything there. It looks like Minneapolis in January. If your light is too low and it's too dark, you can't track anything either. In Scene Kit, happens by default, where, because it's Apple, they pop up this cute little UI that says, by the way, it's too dark. Move to a better lit area. But in Unity, we have to roll our own for right now. So I want to know at just what level, at just what, here we go. At just what state does it drop below a certain value? And with that, I have Pro, so I can do a raw data export, which looks like this. And if you clean it up, it looks like this. And when you grab your ambient light and your tracking state, it turns out you can do something like this. And now I have beautiful sets of data that I can write my own UI that matches my game that says, if my users hit this ambient light in their AR kit game, I can go ahead and prompt them and say, by the way, this isn't great. And all of this is through beta testing. I had this data because I had friends playing the app, Leon, and I was able to make a correlation here, and I can keep this for my future games. Write tests, get your data, make your games smarter, not harder. Thank you so much.